Okay, so now let's talk about the topics that we are going to cover as part of this machine learning course. In the case of supervised learning, we will start studying the linear regression models. These models are the simplest ones that we can study, but even though they are simple, they are very important to understand the principles behind the supervised learning problem in general. After that, we are going to study the classification models, and you will see here that all the things that we learned about linear regression can be modified to talk then about classification. So we can define first a linear regression problem, and then by simply adding some functions, we can get a classification algorithm. After that, we will move and talk about generative learning models. These kind of models are related to probabilistic functions. So the name generative comes from the idea of generating or creating probabilistic functions. After that, we will talk about support vector machines. In support vector machines, we define a supervised learning problem as an optimization problem with multiple constraints. This optimization problem is solved using Lagrange multipliers. And after we have solved this using Lagrange multipliers, we have a numerical algorithm that is going to be very useful for solving these support vector machines. Then we will discuss AdaBoost. In AdaBoost, the idea is to generate several classifiers that are not very good by themselves. These are called weak classifiers. Because of that, they are not very good. But when we generate many of them and we create an ensemble of these weak classifiers, then we have what we call a strong classifier. And this strong classifier is very robust, especially against the overfitting problem that we are going to study later. After that, we are going to cover some aspects of the learning theory. Especially, we are going to discuss formally. So this is mathematically speaking, we are going to define what the concepts of variance and bias are, how they are related. And also we are going to talk about some guarantees of our machine learning models, guarantees about what is the error that we can expect to have in these models depending on the complexity of the model itself. This is how many parameters we are using in our model, and also in terms of how big our data set is, so how many examples we have to train this model. So we are going to talk a bit about that in the learning theory part of the course. Then we are going to discuss or analyze the regularization concept, which is a way to try to reduce the overfitting problem. As we will see, overfitting is a problem that we need to take very much into account when we are training a supervised learning model. And this problem is mainly due to parameters that grows unbounded, and this can create models that are really flexible, let's say, and they can be so flexible that they can even memorize the examples that we are using during the training, and this is not good. As we will see, this will increase the generalization error of our model. So in regularization, we see how we can reduce this overfitting. by adding some terms to our functions. And also we are going to talk about some strategies that we can use for selecting models, because as you will see, we can define or make many hypotheses about what the right model for our problem is, and we will need some way to decide what is the best model for our problem. So we will talk a bit about these strategies for selecting models. Finally, in this part of supervised learning, I will give an introduction to neural networks. I'm going to use everything we have seen at that time, and to introduce the neural network models, which are non-linear models. And I will talk about the main kinds of neural networks that are being used a lot these days, like the convolutional networks, recurrent networks, and GANs networks. Now, in terms of unsupervised learning, we will start with the expectation maximization algorithm, which it can be seen in general as a method or methodology for estimating the values of hidden variables, or also called latent variables. This is usually done in a probabilistic framework. Then we will talk about principal component analysis, and we will see how this method can be used to reduce the dimension of our data. The idea behind principal component analysis is to discover in which dimensions our data is more spread out, so it is easier to solve, for example, clustering problems. Then I will explain a kind of unsupervised neural network, which is called self-organizing maps. And these methods are very powerful, as you will see, for clustering. And finally, in the section of unsupervised learning, we will study spectral clustering. Spectral clustering is a way to perform clustering of data, and we take advantage of a data structure, which is a graph. And in this kind of algorithms, we will represent our data as graphs, where connections between nodes will represent some relationship between each pair of points, and we will represent these graphs using adjacency matrices, and then by performing some operators on these matrices, we will solve the clustering problem. Finally, in the part 3 of the course, we will talk about reinforcement learning. We will start by studying Markov decision processes, which are mathematical tools for solving optimization problems in which you need to select the best or the optimal sequences of actions. Then, once we have studied these Markov decision processes, or MDPs, we're going to study 3 different families of methods that can be used for solving these MDPs. The first family is called dynamic programming. In this dynamic programming, we are going to cover the basic algorithms. Then we will move into Monte Carlo methods. That is a family of methods that is relatively different to the dynamic programming methods, but they are also used for solving MDPs. And finally, we will talk about temporal difference learning methods, methods like Q-learning or SARSA. And these methods are, we can say, like the best of dynamic programming and the best of Monte Carlo in one only kind of methods. So this will be the last topic that we will cover in this course. And to study, you will have some sources of information. First of all, of course, these presentations, so you will have access to the videos, and also I will upload the slides in the Moodle page, so you can download them and study on them. I will be also providing some lecture notes where you can read extended versions of these explanations that I will be giving in these videos. Maybe from time to time I will also add lecture notes from other people. Another important source of information or learning in this case will be the exercises. So it is very important for you to do the exercises. That's the only way to really understand the algorithms that we will be discussing here. Now, in terms of books, I recommend to use the Pattern Recognition and Machine Learning book by Chris Bishop. It is a very good, well-rounded book about machine learning in general, and specifically talking about reinforcement learning. I recommend to use the book by Richard Sutton and Andrew Barton, which is Reinforcement Learning and Introduction. It is now in the 2nd edition. And if you want to get deeper into the mathematics of machine learning, there are 2 other books that I can recommend. The first one is Foundations of Machine Learning, and the second one is Understanding Machine Learning from Theory to Algorithms. These are more mathematical books. They are very good books about machine learning.